Good morning, Year 5, and welcome to your Wednesday morning fluency. Let's have a look, first of all, at what we are going to be doing today. So, you've got morning fluency first, of course, then we've got SPAG, English, maths, read theory, and then this afternoon, computing, and Mr. Wanford is dropping in for a video in German for you. So, without further ado, here are your morning fluency questions. Have a look at them on the quiz. I'm quite pleased with the one for the challenge because it gives you the option to rank them as part of the feature. So that's quite fun, something a bit different. And when you have had a go at completing all of the questions, then come back to me here and we will go through our target questions. Okay, then. So these are our target questions for today. You can see I've already put sort of the scaffolds in place for some of them. So we've got 1/7 plus 5/7 as our first one. And I've got an image of our whole here. And the first thing that we need to do is we need to divide that whole into sevenths. Because the denominators are the same, we only need to do that. We don't need to find out any equivalent fractions. So here is our whole divided into sevenths. Now I'm going to shade in 1/7 in one color, and then I'm going to shade in 5/7. Now, we don't need to worry about the denominator when it's the same. It's just like saying one marble had 5 marbles. So that's a really good thing with fractions. So we've ended up with a total of 1, 2, 3, 4, 5, 6 out of 7 shaded in, which means that 1/7 plus 5/7 is 6/7. Now, the reason that we don't have to count the denominator is because a seventh is just one of these little nodules. It's not being used as a number in itself. So 1/7 plus 5/7 is 6/7. Let's move on to our subtraction. 3 take away 6 I can't do, so I'm going to have to borrow from the tens. 13 take away 6 is 7. 6 takes away 6 is 0. 1 take away 3 I can't do, so I'll borrow from the thousands. 11 take away 3 is 8. And then I am left with 5 over here. Okay, let's have a look at some division. 8,729 divided by 7. 7 goes into 8 once with 1 left over. That's not what I wanted to do. There we go. 7 goes into 17 twice, which gets us to 14 with 3 left over. 7 goes into 32 4 times, which gets us to 28 with 4 left over. And then 7 goes into 49 7 times. So we are left with 1,247. Now, for our multiplication this time, we've got 3 digits that we are multiplying together, but it still works in exactly the same way. So I'm going to start with 5 times 7 because that's the order that we've got it in. But I could start with 7 times 3. I could start in any order. So 5 times 7 is 35, which means that I am left with 35 times 3. Now, what I might want to do is I might want to lay that out using the column method. So 35 times 3. I spoke to some teachers yesterday who said that they have mastered the art of using their scribing on the screen. So it's made me desperate to want to be able to do it. So 5 times 3 is 15. Because I'm only multiplying by a 1-digit number, I'm going to put it underneath because I haven't got to do any adding afterwards. 3 times 3 is 9, plus the extra 1 is 10. Because there's no hundreds column, I can just put that straight in, which means that my answer is 105. And now for my challenge question. Now, because all of these numbers only use 2 digits between them, that's where they tried to confuse us. So the thing that I would always do is I would always write them down and have them all on top of each other, because it's much easier for you to compare the different digits so that you can see, because we always start with the larger digit. The other thing is to really carefully read the question from smallest to largest, which means that the smallest number has to go first. Now I can see straight away that these numbers have got 7 digits, so they are going to be our larger numbers. So let's have a look and see. So these two are the ones we're comparing to see which is the smallest. I can see that we've got the same number of 100,000s, the same number of 10,000s. This number's got 1,000. This number doesn't have any. So this number must be the smallest, followed by this one. Now we are having a look here. So I can see that they've got the same number of millions. This one has got 100,000, which the others don't. So that one must be the largest. This one's got a 10,000, which this one doesn't, which leaves us with this one slap bang in the middle. There we go, guys. Hopefully that has woken your brains up, and I look forward to seeing your work for today.